when the number is equal, when the hydrogen ions are equal, we actually start out in the middle of the scale. We say that this solution has a pH equal to 7. So when you think of a solution that has a pH of 7, it's a neutral solution. Does anybody know what pH your blood is? Can you find it on the, is it exactly 7? It's not exactly 7. Is it better over here? In your book, notice I'm going to your book for this information. The pH scale, which, does anybody know what page that is right off the bat? On page 28. Blood here has a pH of 7.3 to 7.5. So it's not perfectly neutral. In fact, it's just a little bit alkaline. Just a little bit, the synonym to alkaline is basic. So the blood is a little bit basic. Now if we would have, it's easier to work with whole numbers when we first do this, so we'll just do whole numbers today. If we go up to a pH of 8, for an example, turns out that egg white has a pH of 8. It's an alkaline or basic solution, so do you think it's going to have more hydrogen ions or more hydroxide ions? Anybody know? No? Yeah. 50%, yeah. It's going to have more hydroxide ions. So as you go up the pH scale, there are more hydroxide ions than hydrogen ions. And in fact, there's going to be 10 times more hydroxide ions than hydrogen ions. So that's how our log scale here is allowing us to increase or decrease things by 10. Now if we went up to a pH of 9, given that we're moving up by 10s, if we go to a pH of 9, we have a good example. Those phosphate detergents that you might use in your laundry, bleach and Tums have a pH of 9. How many, are you going to have more hydroxide or hydrogen ions? Nope, hydroxide. It's still hydroxide. So we're still going up the pH scale. So we're increasing the number of hydroxide. And can't use the bottom. So at a pH of 9, how many times more hydroxide ions? Going up by 10 from hydrogen. So at 8, we had 10 times more hydroxide ions. So at a pH of 9, we should have 100, multiply. So 10 times 10, you're going to add a 0. 100 times more hydroxide ions. So logarithmic scale, you're going by 10, but you're multiplying by 10. Basically, you're just adding a 0. So we go to a pH of 10. Things like milk of magnesia. How many more hydroxide ions? 1,000. You got the pattern? And then let's just jump to 13, oven cleaner. That's something you want to wash your hands in. pH of 13, figure out how many zeros you're going to add. many?
No, these are the same here.
6 zeros. So 1,000,000 times more hydroxide ions than hydrogen ions. You think that's a really reactive solution? It's oven cleaner, so it probably should be. Yeah, so the more ions, more disproportionate number of ions you have, the more reactive that solution is. It doesn't matter if you're going the basic route or the acidic route. You increase one ion over the other, it's going to be a more reactive type of solution. Now let's talk about the acids.